The next topic that we are going to discuss is inverse Laplace transform. So we know for the function ft, the Laplace transform gives another function in domain S. Similarly, if we apply inverse Laplace transform on f of s, which is represented by L inverse, we get f of t, that is the original function in time domain. So let's see an example. So we know the Laplace of t is 1 upon s square. So the Laplace inverse transform of 1 upon s square will become t. Similarly, the Laplace of cos 2t is equals to s upon s square plus 2 square, that is s upon s square plus 4. So the inverse of s upon s square plus 4 will give cos 2t. Now we will solve some inverse Laplace transform questions. To do that, I have written the basic Laplace transform of some functions on my right hand side. You must remember this for the examination. So if we have to find the Laplace inverse of 4s plus 1 upon s square minus 25. So in these kind of questions, where you can see the denominator contains s square minus something or s square plus something, it means it is of the form cos omega t or sin omega t or cos hyperbolic omega t or sin hyperbolic omega t. So we will reduce it to that form. Now 4s plus 1 upon s square minus 25 can be written as 4s upon s square minus 25 plus 1 upon s square minus 25. This can be further written as 4s upon s square minus 5 square plus 1 upon s square minus 5 square. Now you can see we have reduced the first term to the Laplace of cos hyperbolic omega t. So where omega is 5. So the Laplace of this term will become cos hyperbolic 5t. And for the next term, we see we have nothing in the numerator, but in denominator we have s square minus 5 square. So to bring this of any of these forms, we can multiply by 5 and divide by 5 here. So let's do that. This will become 4 times s upon s square minus 5 square plus 5 upon s square minus 5 square 1 upon 5. Okay. Now the Laplace of first term will become the first term is the Laplace of cos hyperbolic omega t, and the second term is Laplace of sine hyperbolic omega t. So the Laplace inverse will be 4 times cos hyperbolic 5t plus 1 by 5 times sine hyperbolic 5t. This will be the answer. Next question is, we have to find the Laplace inverse of pi upon s square plus 4 pi s plus 3 pi square. So here our motive should be to reduce the denominator term as perfect square. So let's try to do that. So pi upon s square plus 4 pi s plus 3 pi square can be written as pi upon s square plus 3 pi s plus pi s plus 3 pi square. We can take common, so it will become pi upon s plus 3 pi into s plus pi. Now this pi upon s plus 3 pi into s plus pi, we have to split it into two terms so that we can take the inverse of that. To split this into two terms, we need the help of partial fractions. So let's write this in terms of partial fraction. So this can be written as a upon s plus 3 pi plus b upon s plus pi. Okay. Now we have to find the value of a and b, substitute it, and then we can take the Laplace transform of the resulting expression. Inverse Laplace transform. So this can be written as a times s plus a times pi plus b times s plus 3b pi upon s plus 3 pi into s plus pi. This is equals to a plus b times s plus a plus 3b times pi upon s plus 3 pi into s plus pi. Now if we compare this with the original equation, we will get a plus b as 0, because in this original expression there is no s term in the numerator, and a plus 3b will become 1 because the coefficient of pi is 1. From here a is equals to minus b. We can substitute it here. It becomes minus b plus 3b equals to 1, 2b equals to 1, b equals to 1 by 2. Therefore a equals to minus 1 by 2. Now we put these values in our partial fraction. Now we substitute these values of a and b in our partial fraction, and let's see what the expression becomes. So pi upon s square plus 4 pi s plus 3 pi square will become minus 1 by 2 s plus 3 pi plus b times 1 by 2 s plus pi. Now we know the Laplace of e to the power at is 1 upon s minus a. Therefore, from this, the Laplace inverse of our original expression will become minus 1 by 2 e to the power minus 3 pi t plus 1 by 2 e to the power minus pi t. This will be the answer. Now we have to find the Laplace inverse of 3 factorial upon s to the power 5. So we know that the Laplace of t to the power n is equals to n factorial upon s to the power n plus 1. So since here n is 3, it means the Laplace inverse of 3 factorial upon s to the power 4 will be t cube. Now let's see the Laplace inverse of 2 upon s to the power 4 minus 48 upon s to the power 6. So in the similar way, for these kind of questions, we have to see can we make it as Laplace transform of t to the power n, that is n factorial upon s to the power n plus 1. So for the first term, that is 2 upon s to the power 4, this can be written as s to the power 3 plus 1, and in numerator we can put 3 factorial and we can divide it by 3 factorial. 2 was there already, minus s to the power 5 plus 1. On the numerator we can write 5 factorial and divide by 5 factorial. 48 was already there. So this term will be the Laplace inverse of this term will be Laplace of t to the power 3, and this will be Laplace of t to the power 5. So we will get 2 upon 3 factorial t to the power 3 minus t to the power 5. This is the answer. Now let's see the Laplace inverse of those expressions that come from the first shifting theorem. So what first shifting theorem says? Let's revise. It says that if the Laplace of f of t is f of s, then the Laplace of function f of t multiplied by e to the power at will become f of s minus a. We simply replace s with s minus a. Now in the given expression we can see this is s minus 2 upon s minus 2 square plus 4 square. That is, it is of the form cos 4t. It is of the form Laplace of cos 4t with shifted s. So the Laplace inverse will be cos 4t, and for minus 2, that is with s, we have to multiply it with e to the power at. A is 2, so This will be the Laplace inverse of the given expression. Now let's see the Laplace inverse of 24 upon s minus 3 to the power 5. So the given function f of s is 24 upon s minus 3 to the power 5. This can be written as 4 factorial upon s minus 3 to the power 4 plus 1. So this comes from the formula Laplace of t to the power n with shifted s. So the Laplace inverse of f of s will become t to the power 4 multiply e to the power at. A is 3, so e to the power 3t. This will be the answer. Let's see the last problem for the day. So we have to find the Laplace inverse of the given function. So fs is given as 3s minus 137 upon s square plus 2s plus 401. Now our aim should be to convert denominator as perfect square. So this can be written as 3s minus 137 upon s square plus 2s plus 20 square plus 1. Now on the numerator we can write this as 3s minus 140 plus 3, so that we can make 3s and 3 together, upon s plus 1 whole square plus 20 square. Now this will become 3 times s plus 1 minus 140 upon s plus 1 whole square plus 20 square. We can split this into two terms. 3 s plus 1 upon s plus 1 whole square plus 20 square minus 140 upon s plus 1 whole square plus 20 square. Now this is the first term is of the form Laplace of cos of omega t with shifted s. So we have to multiply it with e to the power at. A is 1. And so for this it will become e to the power t into cos of 20t. And for the second one, we have to keep 20 on the numerator so that it is converted of the form Laplace of sine 20t. So we can further write this as 3s plus 1 upon s plus 1 whole square plus 20 square minus 7 into 20 upon s plus 1 whole square plus 20 square. Now Laplace inverse of fs will become 3 times cos 20t multiplied by e to the power at. A is minus 1 here, minus 7 times sine 20t multiply e to the power minus 1t. So this will be the inverse of this expression.